Good morning, everyone. So, today we're taking a closer look at trees. This lesson can be found under abstract data structures. So, firstly, starting with the logical operation of trees. Trees are very well known for being a non-linear data structure. They don't store data in a linear array, like arrays, stacks, queues, or linked lists, but rather they organize the data hierarchically. I have quite some trouble saying this word, but let's move on. So, let's move on to some real life examples. For example, if you happen to have business management as a subject, you surely know that companies also use a tree-like structure to organize themselves hierarchically. And furthermore, we also have the file system on our computer. They also store the folders, the files, everything hierarchically. For example, we have this PC. Under this PC, we have our documents, schoolwork. Another level, we have the math folder. In the math folder, we have our um, exercises, and so on and so on. Also, another very important thing to note is that this computer science syllabus only um, focuses on binary trees. And the important difference to grasp is that trees generally have more than two children, so one manager can have multiple employees. However, a binary tree only can have 0, 1, or 2, so up to 2 children. We'll cover this terminology in the next topic. It's just important to know in our syllabus we only care about binary trees. So now going into, as promised, to the binary tree related terminology, we have a really cool illustration showing multiple terms, starting off with the top with the root. The root is the node at the top of the tree. This can really be seen as a real tree. A real tree also starts with the root, which is below the soil. Just it's everything upside down. It starts at the top with the root. Then we have the children. The children are nodes directly below a particular node. So the children nodes of P would be Q and R. The children nodes of L would be E, F, and G. Also, then the parent would be L. The parent of E, F, and G would be L. So we have a parent-children relationship right here. Then we have the lonely nodes. That they are called the leaf nodes, and the leaf nodes are nodes without any children. In our tree, B, D, H, E, E, F, and G are all leaf nodes. Then another term we need to understand are the levels. The levels are not shown in this illustration, but I will use for the first time the pen and see how it goes. So, assuming that the level at the root node is level 1, also I forgot to mention, a level refers to the amount of generations from the root node. So again, assuming that the root node is at level 1, the children of the root are at level 2. The grandchildren of the root, so the children of Q and R, would then lay at level 3. And so on and so on. Then we have this is level 4. And finally, we have level 5. This is just that simple. We have levels, and levels refers to the amount of generations from the root node. Also, levels, we also have height. It's quite different. The height is the number of levels from the farthest leaf node. So we know that leaf nodes are nodes without any children. So, for example, if we want to know the height of M, we just need to find the farthest leaf node, which would be H or I, and then we see how many levels is this away. For example, this is 1 level away, so the height would be 1. For example, the height of R, again, let's find the farthest leaf nodes, are the same, H and I. We see how many levels is this away. 1 level, 2 levels, 3 levels. So this has a height of 3. And the height of the whole tree would be the height of the root, as the root is on top. If we want to find the height of P, well, it's just 1 more than R, so P has a height of 4. Therefore, our whole tree has the height of 4 levels. Just 2 more concepts to go, and then we are done with the whole terminology. We also need to know what is a path. A path is a list of nodes we must go through to go from one node to another. So let's suppose we want to go from node P to node A. What would be our path? So we know path is a list of nodes, and this list of nodes would be, okay, we start at P, from P we go to Q, and then from Q to arrive at A, we go from Q to A. A path is simply a list of nodes. In a big tree there may be several ways to go to one node, but a path is just important to remember, is a list of nodes. And finally, the last concept we need to understand is a subtree. A subtree is probably one of the most important to understand. May seem a little confusing at first, but will be very important for the next topic. So every node in our tree is the root of a subtree. So, okay, let's start. So in our tree, our root, we only have one root, right? The root of the whole tree would be P. Correct. But let me erase everything so we have a clear picture. Q is also a root of a subtree. Q is the root of the subtree of this whole subtree. If we imagine this only being a tree, Q would be the root. It's just a subtree of the whole tree, a little division. And in this little division, our root would be Q. The same thing applies. If we think this as another subtree, our root would be C. And every single node is the root of a subtree. M is in this case the root of this subtree. And this is just important to understand. The subtree will then consist of the nodes below it. So here's our root, and our subtree continues this way, down. It may be very natural that you don't understand everything right now. Not everything about subtrees. We will review subtrees in the next topic, don't worry. But here you have a little table. If you just want to pause the video and review things you didn't understand. And now we are going into tree traversal. Here is where we will use subtrees and also review it. Don't worry if you don't understand everything until now. So, traversing a tree is the process of visiting every node of the tree. Why would this be useful? Well, let's say we want to find the largest value in the tree. We of course need to visit every single one of them to see, okay, this is our highest value. So in hierarchical structure like a tree, there are several different ways to do it. Let's firstly start with the in-order traversal. It states that we first visit all the nodes in the left subtree, then we go on to visit the root node, and finally we visit all the nodes in the right subtree. Okay, it seems quite easy. We first go to the left, then we go to the middle, and then to the right. But it may be a little bit more complex than you think. Here we have the order. We visit all the nodes, and okay, let's start and see if we understand it correctly. So we start at F. F is our root node, and we only visit root node in the second step. So we for now ignore it, and we go on to visit the left subtree. The left subtree of this whole tree would be this, right? This is our left subtree. Then we go on to B. B has another subtree, has another left subtree. So the left subtree of B would be this. Then we go to A. A has another left subtree, so we don't stop. We, until now, have not visited any node to put in our order. We are just going to the left, to the left, to the left, until there is no more left, and we visit all the nodes. So we now go to the left subtree, where A is our root. And we go on and ask A, what is your left subtree? A goes and sees if there is something. There is no left subtree. So in this subtree of where A is the root, we go back. We are now in A, and we visit our root node. In this case, A is our root node, so we start and put A in there. So now we visited A, and we go back and we visit the root node of this subtree, where B is the root. Okay, so we now A, and now we have B. B, now we visited B, a root node, and B has a right subtree. So we go on to visit roots, the right subtree of B. And D has a left subtree. We now visit the left subtree, and then we visit the right then we visit the root, and then we visit the right subtree of B. We then go back, visit the right subtree of F, and it goes on and on and on, always in this order. And this is basically everything into the in-order traversal. It may seem quite complex, but once you understand the concept of subtrees, we'll quickly grasp it. So let's continue just to see if we understand everything. So we go now to D. D has a left subtree. So we go and visit C. C goes back. C goes back to the root node. Root node is D. Then we visit E, which is the right subtree of D. So we go on and put E. Then we go back and visit all the root nodes. We go back, we already visited D, so we are not putting D in our sequence. We already visited B, so we are not putting B in our sequence. And from B, remember at the start we had this whole subtree right here. So we go back, now we are going back, and we visit F. Going back, now we visit F's subtree. At the beginning, we only looked at this part. Now we are looking at this whole part. We visit, we go to G. G looks, okay, do I have a left subtree? I don't, so I go back to G. I put G in here. I go to the left, now I go to the right. I visit the left subtree of H, of E, it's H, and then I go back to the root of H, which is E. I know, it's hard, it's complex, just look at it for a few seconds, a few minutes, and it should come to life somehow. I also got a little, I also needed a little time. But once you grasp it, the others will be as easy. We also have the pre-order traversal, which is just another order. So here we started with the left subtree. Here we are starting with the root node and then going to the left subtree, then to the right subtree. And for the post-order traversal, we start with the left, then right, and then root. I will not go in detail in this other two ways you can do it. Because otherwise the video will be very long, and it's also better if you go on and try to understand it yourself. And me explaining it here, in my head it sounds very logical, in yours it may sound just like garbage, and if you go on to look at it and try to understand it by yourself, it will help a lot. So I didn't yes, I challenge you to do that. And well, this was the whole video. This was the resources I used. I did not expect that you understand the traversals at the moment instantly. It's expected that you look at it again and then you try to put this inside your head. But I really hoped I helped you in some way. And until next time, bye bye.